Hello, and welcome to the lecture on 3.3. Today we're going to talk about dividing polynomials. Let's start with something from way back with long division. Now, we're going to talk about long division of polynomials in a second, but first we're going to talk about the long division of just numbers so that we can get a handle on what we've done a long time ago. So recall integer long division. So let's start with just a fraction, and we'll get some terminology down again. So if we were trying to divide 125 by 7, we would call this the dividend. The denominator is called the divisor. 125 divided by 7 is equal to 17 plus 6 over 7. Now this part here, the 6 here, is the remainder. And we'll get into that in a second. And then 17 would be your quotient. What happens when you actually divide. Now, if we multiply both sides by 7, we can rewrite this expression to say that 125 is equal to 17 times 7 plus 6. And this is where we usually get the remainder. So here, this would be our remainder. Now, it'll be easier once we get into the actual division. So if we wanted to divide 125 by 7, we would say, how many times does 7 go into 125? And we look at this, and we can look at individual digits. So does 7 go into 1? No. Okay, well then combine the first two digits. Does 7 go into 12? Yeah, it goes in one time. We put a 1 above the 2. 1 times 7 is 7. And then we do 12 minus 7. Don't forget to subtract. That will become important later when we do polynomial division. So 12 minus 7 is going to be 5. And then we bring our other 5 down. So we end up with 55. Now, how many times does 7 go into 55? That's 7. 7 times 7 is 49. Again, do not forget to subtract. We subtract, and we're left with a remainder of 6. 55 minus 49 is 6. Our answer to 125 divided by 7 is 17 with a remainder of 6. Now, this is a long time ago, so if you don't remember, it's not a huge deal. We're going to talk about polynomial long division in this section, though, so it helps to remember. Division algorithm. This is very commonly used, but rarely discussed. If p of x and d of x are polynomials with d of x not equal to 0, then there exist unique polynomials q of x and r of x, where r of x is either 0 or of degree less than the degree of d of x, such that d of x divided by d of x is equal to q of x plus r of x over d of x. Now you'll notice that this matches what we have here in our recall statement. We have our p of x. If 125 was a polynomial, we would have a p of x here. We would have our d of x here. This would be q of x, and then our remainder would be over d of x, which is the same here and here. So this is the division algorithm. Now, we have some terms for these. D of x is called the dividend. D of x is called the divisor. U of x is called the quotient. R of x is called the remainder. Now, any polynomial division will follow this path. Now, the key is to actually figure out what q of x is and what r of x is. So let's move on to an example. Find x cubed plus 4x squared minus 12x minus 5 divided by x minus 3. So here we're looking for the quotient and remainder. And we have our dividend and our divisor. So in our division algorithm, we would have p of x divided by d of x. So this would be our p of x. This is our d of x. We're looking for q of x and r of x. Now, polynomial division is very similar to long division of integers. We have x minus 3 is being divided into x cubed plus 4x squared minus 12x minus 5. So again, we have our dividend and our divisor. Now here, what we're looking for is what we need to multiply by this polynomial to get an x cubed in our first term, because we want to eliminate as many of these terms as we can. So what we want to do first is start with something that we multiply by x to get x cubed. Now that something will be x squared. So we put an x squared up here. And we multiply x squared by both of these. So x squared times x is x cubed, so I'm going to write that. X squared times negative 3 is going to be negative 3x squared, so we subtract 3x squared here. And then we subtract. Now this is very key, so please pay attention here. When we subtract, do not forget to distribute this negative. Okay, just like when we subtracted in integer long division, we're subtracting in polynomial long division. So we would have x cubed minus x cubed. These will cancel, and that should make sense. This should always happen because we select this value specifically to make the first term disappear when we subtract. We chose x squared in such a way that x squared times x would be x cubed. And then 4x squared minus a negative 3x squared will be 7x squared. Because if you distribute this negative, we would have a negative x cubed, and then this negative will cancel this negative out, and we'll end up with 4x squared plus 3x squared, which is 7x squared. Then we carry down our negative 12x. We have 7x squared minus 12x. Now, whenever we're choosing a value up here to be part of our q of x, and you'll see that at the end, but why it's q of x. Whenever we're choosing a value for q of x, any term but the first term, we just ignore. We ignore all terms except for the first term. So we choose the value up here so that when it multiplies by x, the first term in our divisor, it will be whatever the first term is here. So here, we're trying to figure out something times x to give us 7x squared. So we ask ourselves, what times x will give us 7x squared? And that's going to be 7x. So now we multiply 7x times x, we get 7x squared. And then we multiply 7x times negative 3, and we get a negative 21. And we repeat the process. We subtract. So again, 7x squared minus 7x squared, this will cancel. And again, that should make sense because that's how we chose our 7x, specifically so that we could cancel this first term out. Then do not forget to distribute your negative. So when we distribute this negative here, we would get a plus. So we would have 12x plus 21x, which of course is 9x. And we carry down our negative 5. So we have a negative 5 here. Now we need to multiply. We're trying to find something that we multiply by x to give us 9x. And that will be just 9. Plus 9 here. 9 times x is 9x. 9 times negative 3 is negative 27. And then we subtract, just like every other step. Do not forget to distribute negative. I will repeat that all the time. It's a common mistake. Students do it all the time. I guarantee you at least one of you will do it. 9x minus 9x is going to be 0. These cancel. And then a negative 5 minus a negative 27 would be the same thing as negative 5 plus a 27 will be 22. So this is going to be our remainder. Ask yourself, why do we stop here? Why are we stopping at 22? It's because it's actually lower degree than this polynomial. So remember from the division algorithm, where r of x is either 0 or of degree less than the degree of d of x, where d of x is here, or r of x is here. And it should also make sense logically. The next thing that we would want to ask ourselves is, what can we multiply times x to give us 22? Well, nothing really. Nothing that would be a polynomial anyway. You would have to divide by x, which we're not going to do. So we just leave this alone and we say, well, this is going to be this quotient, x squared plus 7x plus 9, plus our remainder, 22, divided by our divisor, x minus 3. So again, here's our divisor, d of x, our remainder is r of x, our quotient, q of x, and our divisor again is x minus 3, and here's our dividend. So what we would say here, if we wrote it in the form of the division algorithm, we would say that x cubed plus 4x squared minus 12x minus 5 divided by x minus 3 is equal to x squared plus 7x plus 9 plus 22 over x minus 3. And that would be it. That's as far as we can go. I want you to try one now, and then we'll do another example. It's a little bit more complicated. Find d of x, d of x, q of x, and r of x. If we have the division x minus 1 is being divided into x to the 4th plus 5x cubed plus 3x squared minus 2x plus 5. Okay, we're going to do one more example. This one's going to be a little bit more complicated. You do need to pay attention in this one as well, because there are some tricky parts to this problem. What we're going to do in this problem is our divisor is not going to be a linear term. We'll have x squared plus 1 is dividing into 2x to the 5th minus 3x to the 4th minus 12x cubed minus 3x plus 12. So I want you to notice something very quickly here. What we're dividing into has no x squared term. So notice that there is no x squared term here. Now, what we do in order to still use this process is we write a 0x squared term. This is the same thing as having no x squared term, because it's just 0 times x squared. No matter what x squared is, this will become 0. So it's the same thing as not having this term. But the reason that we write it is for a placeholder, and hopefully you'll see that. I'll point it out when we do the process. So our first step is to figure out what we need to multiply by x squared in order to get 2x to the 5th. So what do we need to multiply by x squared in order to get 2x to the 5th? That will be a 2x cubed. 2x cubed times x squared will give us 2x to the 5th. 2x cubed plus 1 will be plus 2x cubed. And then we subtract. We have 2x to the fifth minus 2x to the fifth gives us a 0. Then we'll have a negative 3x to the fourth minus 0. So this will carry down. And then negative 12x cubed minus a 2x cubed. That'll be negative 14x cubed. Next, we carry down our x squared term. This might not be immediately obvious, and that's okay. When you get into a few of these problems, you'll hopefully realize that you need to carry this term down. But the next thing is, what do we multiply by x squared in order to get a negative 3x to the fourth? Just be a negative 3x squared. Negative 3x squared times x squared is negative 3x to the fourth. Negative 3x squared times 1 is going to be a negative 3x squared. Now you want to make sure that you align everything correctly in the column with the same degree. So here I align my negative 3x to the fourth in my x to the fourth column. I have an x to the third column that this doesn't multiply by anything to give us anything here. So we're going to have a 0x cubed here. And then our negative 3x squared times 1 gives us something in the x squared column. So we use the x squared column here. And then do not forget to subtract. I know I say this every time, but notice that this is where our 0x squared term will be used. This is just a placeholder, but it's a placeholder that gives us value. Negative 3x to the fourth minus negative 3x to the fourth is the same thing as saying something minus itself. These will cancel. This negative 14x cubed minus nothing just gives us a negative 14x cubed. And then 0x squared minus a negative 3x squared will give us a positive 3x squared. And then we carry down our negative 3x. It'll be the next term that we need. So the next thing that we're looking for is something that multiplies by x squared to give us negative 14x cubed. And we should see the pattern by now. This should just be negative 14x. Negative 14x times x squared gives us a negative 14x cubed. Negative 14x times 1 is a negative 14x. And we will, of course, subtract. Negative 14x cubed minus a negative 14x cubed cancels out. Then we have our 3x squared minus nothing gives us a 3x squared. Negative 3x minus a negative 14x will give us a positive 11x. Then we're looking for something that multiplies by x squared to give us 3x squared. So we add 3 here. I carry my 12 down. 3 times x squared is 3x squared. 3 times 1 is 3. And we subtract. 3x squared minus 3x squared is 0. That's by design. 11x minus nothing is 11x. 12 minus 3 is 9. Now, we can't do anything else after this because we can't multiply by x squared to give us an x and still have a polynomial. So instead, we just tack this on as our remainder. So plus 11x plus 9 divided by x squared plus 1. So here's our remainder. Notice that it's a degree less than the divisor. That's also in the division algorithm here. as I stated before. All right, the next thing we're going to talk about is synthetic division. Note, now this is a very, very key note. This is very, very important when using synthetic division. Synthetic division can only be used when the divisor is of the form x minus c. Now, it doesn't matter what c is as a real number. Obviously, it has to be a real number. But other than that, it does not matter. It could be a fraction or it could be a whole number. It doesn't matter. But synthetic division can only be used when the divisor is of the form x minus c. Synthetic division uses the coefficients of the dividend to quickly divide polynomials. This is a description of what we're doing. I think it's easiest if we just do an example here to show you what I mean by this. Let's find 2x cubed minus 4x squared plus 3 divided by x minus 1. Now, x minus 1 is a pretty easy divisor, but let's go ahead and work this anyway. And we're going to work it in two ways. Do long division in one way, so this would be x minus 1 divided into 2x cubed minus 4x squared. Don't forget your placeholder, plus 0x plus 3. And then synthetic division we'll do over here. Let's start with long division just for the practice. What times x gives us 2x cubed? That would be 2x squared. 2x squared times x is 2x cubed. 2x squared times the negative 1 is negative 2x squared. Now we just subtract. Two x cubed minus 2x cubed is 0. 4x squared, negative 4x squared minus a negative 2x squared, with the same thing as negative 4x squared. When this distributes, it cancels. So negative 4x squared plus 2x squared will give us a negative 2x squared here. And then we bring down the 0x here. Now, what times x gives me a negative 2x squared? It'll be a negative 2x. Negative 2x times x is negative 2x squared. And then a negative 2x times a negative 1 gives us plus 2x. Subtract. Steps are all the same of integer long division. Negative 2x squared minus negative 2x squared. That gives us a 0. Of course, 0 minus 2x is a negative 2x. We bring down our 3, just like before. It's 3 here. And then we have to figure out something times x that gives us a negative 2x. That will be negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2. And then we subtract again. Again, don't forget to distribute your negative. It helps to write parentheses to remind yourself to distribute your negative. So here, this negative needs to distribute to both because the parentheses are here. Negative 2x minus a negative 2x is 0. 3 minus a 2 is 1. So our remainder will be 1 divided by our divisor here. It's minus 1. So the next thing that we're going to do is do the exact same division, but using synthetic division instead. Now remember, synthetic division uses the coefficients of the dividend. Now I know I haven't explained that yet, but what we're going to do is we're going to take the coefficients of our dividend here and write them out. Now what I write in blue here, you do not need to write. I'm just trying to, this is a teaching method. It's to help you understand where the numbers are coming from. So our x cubed term has a coefficient of 2, so I'm going to write a 2 here. My x squared term has a coefficient of -4, so I write a -4. My x term has a coefficient of 0. Notice I don't have an x term. That means it has a coefficient of 0. And my constant term has a coefficient of 3. Then I write a number here from the denominator. This comes from the divisor. X minus 1 means that I write a 1 here. Notice that it changes the sign. Now there's a couple of ways to teach it. There's a couple ways to learn it, but I teach it in such a way that this negative, the x minus 1, becomes just a positive 1 here. And synthetic division is always done the same way in the first step. The 2 comes down. So we have then a 2 here. Now, what we then do is multiply this 1 times this 2, and we write the result here. So 1 times 2 is 2. We write a result here. And then we add, and then repeat. So -4 plus 2 is -2. -2 times 1 will give us a -2. And then we add, 0 plus -2 is -2. Multiply, -2 times 1 is -2, and add 3 plus a -2 is 1. So now I want to make a note here that this is now our x squared term. So it was originally an x cubed coefficient. This will now be an x squared coefficient. So when we write out our result, it would be 2x squared minus 2x minus 2 with a remainder of 1. Or we can rewrite it as 2x squared minus 2x minus 2 plus 1 divided by our divisor, which was x minus 1. This would be the result, which of course is the same thing as we got here. Should try one now? Use both long division and synthetic division to find x cubed minus 3x squared minus x plus 3 divided by x minus 1. Let's do one more example. X cubed plus 6x squared plus 5x minus 6, all divided by x plus 2. Okay, I want to show you a couple of things here. First, we're going to just do synthetic division. So we start with our coefficients, 1, 6, 5, -6. Write these out again, just for a helpful guideline. 1, 6, 5, -6. And we are dividing by x plus 2, so we write a -2 here. So the 1 comes down. One times -2 is -2. 6 minus 2 is 4. 4 times -2 is -8. 5 minus 8 is -3. And -3 times -2 is 6. And -6 plus 6 is 0. Since we got a 0 remainder, what this means is that x plus 2 divides evenly into this polynomial, right? So I can rewrite x cubed plus 6x squared plus 5x minus 6 is equal to x plus 2 times the polynomial with these coefficients, x squared plus 4x minus 3. Now, you might be able to see that if we divide both sides by x plus 2, then we would have exactly this quotient that results in x squared plus 4x minus 3, which is what we have here. You have to remember, when we divide using synthetic division, we're always reducing by 1 degree. We had a degree 3 here, now we have a degree 2, because we're dividing by a single degree. always in synthetic division. Now, in long division, it's a little bit different because in long division, you can divide by higher ordered polynomials, but not in synthetic division. The next thing that I want to talk about is the remainder theorem. If the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Now, what this means is that if we try to find the remainder of p of x upon dividing by x minus c, and you just want to find the remainder, all you have to do is plug c into the polynomial, and you'll find it. I want you to try one. I think that this theorem is easy enough that you should be able to do one without an example. So I want you to find, upon dividing, p of x is equal to x to the 71st minus 2x to the 15th plus x to the 10th plus 3 by x minus 1, find the remainder. This problem should take you less than a minute, just as an idea. It might take you a few minutes to figure out what to do using the theorem, but once you actually figured out what to do, then the problem itself will take less than a minute. The next thing that I want to talk about is the factor theorem. C is a 0 of p if and only if x minus c is a factor of p of x. I'm going to show you a proof here, and then we'll do an example. If you don't want to see the proof, that's fine. You can skip ahead. But I think that this sort of might give you a little bit more understanding into the division algorithm itself. Recall that p of x can be written as q of x times d of x plus r of x, where we have our dividend, our divisor, our quotient, and our remainder. So we're going to do, this is an if and only if statement, so we need to prove both ways. So we need to prove that if c is a 0 of p, then x minus c is a factor of p of x. And that's where we're going to start. So let it be true that p of c is equal to 0. This means that c is a 0 of p. Now I'm going to write my p of x in this form, where my divisor is x minus c. So p of x will be equal to q of x times x minus c plus r. Now I can write r as a constant because my divisor is degree 1. Therefore, if I have a remainder, it's got to be less than degree 1, which is degree 0. So it has to be a constant. So we would have this form for p of x if my divisor is x minus c. Now, if x minus c is in fact a factor of p of x, then my remainder will be 0. So we've assumed that p of c is equal to 0. Let me rewrite that. P of c is equal to 0. But if I plug in c to p of x, then I would have to plug in c to every x on the right as well, and I would get q of c times c minus c plus r. Now q of c can be anything because c minus c is 0, so this entire term will be 0. So we have 0 plus r is r, and we have a 0 here. So now we can see that my r is equal to 0, which we then can amend our p of x to be equal to q of x times x minus c. So this means that p of x can be factored into some function, some polynomial q of x times x minus c. This means that x minus c is in fact a factor of p of x. So now let's do the opposite direction. Let's assume that x minus c is a factor of p of x and show that c must then be a 0 of p. So we let x minus c be a factor of p. Now this means that p of x can be written as q of x times x minus c. Right? Now if we just plug in p of c, we'll see that we get q of c times c minus c, which then gives us a 0, because c minus c is 0, so we would end up with p of c is equal to 0, which then means that c is a 0 of p. So we've shown what we needed to. Let's go ahead and do an example. Let p of x equal 7x cubed minus 2x squared plus x minus 6. And we're going to check to see if x minus 1 is a factor of p of x. Is x minus 1 a factor of p of x? So if it is a factor of p of x, the factor theorem says that p of c would equal 0. So if we plug in 1, we should get 0 as a result. So our c being 1, of course. P of 1 will equal 7 times 1 cubed minus 2 times 1 squared plus 1 minus 6. 7 minus 2 plus 1 is 6, and 6 minus 6 is 0. So this is true. X minus 1 is a factor of p of x. Now I'm going to go ahead and give us a little bit more practice with synthetic division and try to figure out how p of x factors when we have x minus 1 as a factor. So what I'm going to end up doing is p of x divided by x minus 1 so that I can show you what p of x looks like when it's factored using x minus 1 as a factor. So the 1 goes in the box, and then we take our coefficients of p of x, 7, negative 2, 1, negative 6, 7, negative 2, 1, negative 6, and remember, this is an x cubed term, this is an x squared term, this is an x, and this is a constant. Usual, 7 comes down, 7 times 1 is 7, negative 2 plus 7 is 5, 5 times 1 is 5, 1 plus 5 is 6, 1 times 6, 6, and we get a 0 here. So now we have our x squared term, our x term, and this is our constant. So if we divide p of x by x minus 1, we get this polynomial here, which means then that p of x is equal to 7x squared plus 5x plus 6 times x minus 1. And that's it. So we can rewrite this entire polynomial in its factored form, or in a factored form. All right, that's going to be it for today. I will see you all at the next lecture.